Alright guys, welcome to lesson 7, which is calculating empirical and molecular formulas for a compound. So let's talk about empirical formula. Empirical formula is the smallest whole number ratio of atoms in a compound. That means that they cannot be reduced any further. So let's look at an example. So we have B10G20. That would be considered what we have as the formula. The empirical formula would be if we were to reduce this to the least whole number ratio. 10 and 20 are both divisible by 10, so if we divide 10 by 10, we would get 1, and 20 by 10, and we get 2. So the empirical formula, or the smallest whole number ratio of atoms in the compound, would be B1G2. Let's look at an example. What if you had C2H6? If you were to reduce this to the least whole number ratio, you would reduce your subscripts. You would be able to divide each subscript by 2. And you would get CH3. The molecular formula is different. The molecular formula is the actual formula, which is the actual number of atoms in a compound. They're a whole number multiple of the empirical, which means that you would take the empirical formula and multiply it by a whole number to get the molecular formula. So for example, if we're looking at CH4 as an empirical formula, that could be the empirical formula for a molecular formula of CH4, C2H8, C3H12. We can go on and on and on. So what we did is to go from CH4 to C2H8, we just took our empirical formula and multiplied it by 2. For C3H12, we took our empirical formula and multiplied it by 3. So let's look at an example again. So we now have the empirical formula of B1G2, and we now have the molecular formula of B10G20. So we took our empirical formula and multiplied it by 10. So if we have an empirical formula of CH3, and I wanted to know what the molecular formula was, I could multiply it by 2 and get C2H6, and that would be a molecular formula because it is a multiple of our empirical. More examples. So if we're looking at our molecular formulas here on the left, and we look at our empirical formulas, our least whole number ratios on the right, if we were to reduce N2O4, we'd get NO2. If we were to reduce C3H9, we'd get CH3, and so on and so forth. The empirical formula is a least whole number ratio for the elements in the molecular formula. So you can determine the empirical formula. So you can divide the subscripts in a molecular formula by the greatest common factor. So if we have a molecular formula of C4H10, if we divide 4 and 10 by 2, that's the biggest, greatest common factor, or the biggest number that we can divide both 4 and 10 by, we get an empirical formula of C2H5. So I want you to practice determining the empirical formulas from the molecular formulas for these 5 compounds. So pause the video and unpause it when you're ready. Welcome back. So when we're looking at 1, C6H12O6, the empirical formula for that would be CH2O. For N2O4, it'd be NO2. For BaCl2, it would actually be the same. For C2H6, it would be CH3, and for CH3, it would be CH3. Now we can calculate empirical formulas. If you're given numbers, masses, or percents for each of the elements in the empirical formula, you can physically calculate it. So there's 3 steps you're going to do. So you're going to find the mole amounts for all the elements in the formula. You're going to divide each mole by the smallest mole, and you're going to round to the nearest whole number. So let's look at an example. So determine the empirical formula for a compound containing 2.12 grams of chlorine and 1.20 grams of calcium. So you have to find the mole amounts for both the chlorine and the calcium. So for chlorine, we'd take 2.12 grams of chlorine times 1 mole of chlorine over the gram formula mass of chlorine off the periodic table, and we get 0.0660 moles of chlorine. We do the same thing for calcium. So 1.203 grams of calcium times 1 mole of calcium has a gram formula mass of 40.08 grams of calcium. And when we divide these two out, 1.203 by 40.08, we get 0.0300 moles of calcium. So that's step 1, find the mole amount. Step 2 tells us to divide by the smallest whole number. So after we've calculated this, the smaller of the two is going to be 0.300. It's the smallest mole number. So next, we're going to divide each by the smallest mole number. So chlorine divided by 0.0300 is going to be 2 moles of chlorine, and calcium is going to be 1. So when we put that into a formula, this means that we have one calcium atom for every 2 chlorine atoms. And that formula looks like the following. We have 1 Ca and 2 Cls. Another example is if you're given weights or percents. You can also calculate the empirical formula. So I found this little poem to try and help you solve. So you turn your percent to mass, you turn your masses to moles, you divide by small, and then you multiply till you get a whole number. What does that mean? We're going to go step by step. So a compound weighing 298.12 grams consists of 72.2% magnesium and 27.8% nitrogen by mass. What is the empirical formula? The first thing you need to do based on our little rhyme is go from percent to mass. So we're going to go from percent to mass. So we have 72.2 divided by 100. That'll give us the decimal amount times 298.12 grams. So the mass of magnesium is going to be 215.24 grams. We're going to do the same thing for nitrogen and get 82.88 grams. Now what we're going to do is we know now how much mass is magnesium and how much mass is nitrogen. Now what we're going to do is we are going to convert both the mass of magnesium and the mass of nitrogen to moles. So we're going to take the mass of magnesium divided by the molar mass of magnesium and get 8.86 moles. We're going to take the mass of nitrogen divided by the mass of nitrogen in 1 mole, and we're going to get 5.92. So we've done percent to mass, mass to mole. We have to divide by small. So out of these two, which is the smallest, nitrogen is the smallest value, so we're going to divide both by nitrogen's mole value. So magnesium is going to be 8.86 moles divided by 5.92 moles. That gives us 1.5. And nitrogen, when we do the same thing, we're going to get 1. And now we have to multiply till whole. What can we multiply 1.5 by to get a whole number? The answer to that is 2. And that'll give us a whole number of 3. Then what we're going to do is we're going to do the same thing. If you do it to magnesium, you have to do it to nitrogen as well. So since we had to multiply magnesium's value by 2, we have to multiply nitrogen's value by 2 as well. So that'll give us a 3:2 ratio, and our formula will turn into Mg3N2. And that is our empirical formula. Let's look at a practice problem. So we're going to look at the analysis of a compound containing chlorine and lead. So in this empirical formula, you're going to figure out how many leads are you going to have and how many chlorines. So first it says that the compound is 59.37% lead and the rest of it is chlorine. So when you're given problems like this, I'll give you a hint. You assume that you have 100% to start off with. So 59.37% of it is lead and the rest is chlorine. If you subtract 100 and 59.37, you can figure out how much chlorine you have. So pause the video, and when you're ready to look at the answer, unpause. Great, well, welcome back. So here's where we're at. So we have to go from percent to mass first. So percent, if we know that lead has a percent of 59.37, we know that we're going to have 59.37 grams. And 59.37 subtracted from 100 is 40.67. So that means we're going to have 40.63 grams of chlorine. Then we go from mass to moles. So we change both our lead and chlorine mass amounts to moles by dividing by their molecular formulas or their gram formulas. We're going to divide by small, so we're going to divide by the smallest whole number, which in this case is going to be lead. And in this case, we do not have to multiply by anything because these numbers are close enough that we can round. So 3.97 can be rounded to 4. So our formula for this empirical formula is going to be PbCl4. Let's look at practice 2. Pause the video, try this on your own, and unpause when you're ready. Great, well, welcome back. Well, we have vanadium oxide is used as an industrial catalyst. The percent composition of this oxide is 50% 56% vanadium, and 44% oxygen. Determine the empirical formula for vanadium oxide. So we got to go from percent to mass for both. We have to go from mass to mole for both. Divide by small. Multiply till whole. And our empirical formula will be V2O5. Try this, check your understanding on your own, and we're going to go over it in class tomorrow. So now, what if you're given what if you're asked to calculate the molecular formula from the empirical formula? So you're going to first calculate the gram formula mass of the empirical formula. I will always give you the molecular formula mass. So you're going to divide the molecular formula mass by the empirical formula mass, and you're going to multiply all the subscripts by the number that you calculated in step 2. So let's look at an example. The empirical formula of ethylene is CH2. Find the molecular formula if the molecular mass is 28.1 grams per mole. So we need to calculate the empirical mass of CH2 first. So we're set it up 1C times 12 plus 2 H's times 1. That gives us 14. And we plug into our formula, the molecular mass divided by the empirical mass. So we're going to take 28.1 grams divided by 14, and that gives us 2. That means that we need to multiply our empirical formula by 2, which means that our molecular formula would be C2H4. Let's try this practice. Pause the video and unpause when you're ready. Great. What is the molecular formula of a compound that has an empirical formula of NO2 and a molecular mass of 92? First thing you need to do is find the empirical mass of NO2. The empirical mass of NO2 is 46.0 grams per mole. Plug into our equation, so 92 over 46, and we're going to get 2 again. So we're going to multiply NO2 by 2 and get N2O4, and N2O4 is our molecular formula. Let's look at another practice. Pause the video, and when you're finished, unpause to learn the answer. Great. A compound has an empirical formula of HCO2 and a molecular mass of 90 grams per mole. What is the molecular formula of this compound? As always, calculate the mass of the empirical formula first. We get 45.0. Then put molecular mass over empirical mass, and we end up with 2 again. Multiply your empirical formula by 2 and get H2C2O4. Final practice. If a compound has a mass of 45 grams per mole and an empirical formula of CH3, what is the molecular formula? Pause the video and unpause when you're ready. Great, well, welcome back. Calculate the empirical mass. Plug into our formula. We get 3. And so we multiply our empirical formula by 3 to get our molecular formula. Check your understanding. Try this at home, and we'll go over this in class tomorrow.